Okay, so hi everyone. So in this work, we have proposed a collaborative ad transparency method to infer, without the cooperation of ad platforms, the targeting parameters that advertisers are using to target their ads. And one thing that was very important for us is to have a method and have solid proof that it can actually work in the real world and understand the precise conditions under which we can achieve a high accuracy. So the premises of this work is that targeting technologies have been misused and weaponized in the context of election, and probably you already heard about the Russian interference in the 2016 presidential election. So for the ones that haven't, there was this Kremlin-based organization that sent ads that had very divisive content, and they were targeting these ads on Facebook to people from vulnerable groups such as LGBT or African Americans. The other scandal is related to Cambridge Analytica. So for the ones that have not heard, they were a political consultancy company hired by Donald Trump. And what they are known for is that they have targeted ads with political content, and the messages were congruent with the personality of people. So if we take a step back, the reason why these targeting technologies pose a big threat to our society is because they go beyond commercial advertising and they can enable information targeting. And effectively, this technology gives everyone the possibility to use users' personal data to manipulate them. And of course, these threats are so important that governments around the world are also trying to take some serious action. For example, in Europe, they are working on several acts, such as the Digital Services Act, the AI Act, the European Democracy Action Plan, and all of them are trying to regulate online platforms in order to reduce such harms. And transparency, it's one of the important points in this law. And if we look at the Digital Services Act, in Article 30, there is a provision that says that very large online platforms that displayed advertising will need to provide information of whether the advertisement was intended to be displayed specifically to one or more particular groups of recipients of the service, and if so, the main parameters used for this purpose. So this new legislation, it's new, it was voted in 2022, and it will start being enforced and applied in 2024. Other than this, now from a platform's perspective, so despite all these potential and actual harms that have been shown, previous auditing studies, out of which two from our group, have shown a lack of micro-targeting transparency that is provided by these platforms. And for example, online platforms such as Facebook and Google and Twitter, they allow users to ask what are the reasons they have received a particular ad. And this is the kind of explanation that users can get. However, in 2018, we had a study that was showing that these explanations are incomplete, and they were only showing one parameter out of potential many targeting parameters used by advertisers. Fortunately, since then, Facebook revamped their explanations, and now they are more complete. Then the other thing that we have is that ad platforms have started to provide these ad libraries for ads containing political content. Now, in these ad libraries are really nice to have, but they don't contain information about the micro-targeting parameters chosen by the advertisers, in addition to not containing all the political ads. Okay, so given this situation, we wanted to find out whether we can infer the reason why an ad has been targeted without the cooperation of ad platforms. So the idea behind this collaborative ad transparency approach is to monitor a sample of users and the ads that they are receiving, and infer the micro-targeting parameters used by advertisers from the characteristics of the users that received this ad and the characteristics of the users that did not receive this ad. And if you are looking at this image in these slides, let's assume that these are the users that we are monitoring, and these are the users that receive the particular ad. The whole, what you can see is that the users that receive the ad, they all have either black or blonde long hair. Yeah, so this is the kind of information that we want to exploit in order to infer what were the targeting parameters of this ad. So to make the inference, we consider that the ad targeting formula, it's a combination of two attributes. Users interested in sports and coffee, and we call this theta. For the ad delivery, we assume that every user that is satisfying the targeting formula has an equal probability of receiving the ad. So this is known as the Bernoulli assumption, and this probability is the ad budget K divided by the number of users that satisfy a particular targeting formula. So the likelihood of observation given a targeting formula, you can see it here. So quickly going through it, so P theta is the probability of being shown the ad, NMR is the number of monitored users that receive the ad, and this is the number of monitored users that satisfy theta but did not receive the ad. So intuitively, this computes the likelihood of observation given a particular targeting formula. So assuming that the advertiser has targeted people interested in sports and coffee, what is the likelihood that these 3 users received the ad and these other 3 users did not receive the ad? And of course, what the inference method is outputting the targeting formula that is maximizing this likelihood, the likelihood of observations. Okay, so to test this method, we built a monitoring tool that we called AdAnalyst, which is a browser extension. And this tool is basically collecting the ads users are exposed to on social media when they browse on Facebook. And it also collects information from their ads preferences page. So this page contains information about what behaviors and interests the platform infer about these users. And we ask 420 users to install our monitoring tool. So to see if the inference is accurate, if our inference method is accurate, we perform controlled real-world experiments. So what we did is that on one side, we asked the 420 users to install our tool. So we were able to observe the ads that they are receiving and the characteristics that they have. And on the other side, we acted as an advertiser. So we created several ad campaigns where we targeted people that had various combinations of two attributes. So in total, we had 45 campaigns that were reach 3 or more of our monitored users. And this is not always obvious to obtain with a limited academic budget. And then we try our inference method to see whether it's able to infer the actual targeting formula that we specify. And what we saw is that we were able to accurately infer the targeting formula for 17 of these ad campaigns. So these results are very encouraging because despite the complexity and despite that we do these experiments in the real world, we were able to infer correctly, at least in some cases, the actual targeting formula. But the problem is that because we are limited in the number of experiments that we can do on the actual platform, we were not able to understand what are the precise conditions under which we can expect reasonable accuracy. So for this, what we did is that we built this simulation framework. So here we generated a representative synthetic population. And each user was represented as a binary vector that either said that they have an attribute or they did not have an attribute. And to generate these metrics, we use an approach based on adjusted correlated vectors, where the joint attribute probability matches up to the second order the distribution of the actual Facebook population. So using this, we generated 1 million, the profiles of 1 million users over 300 attributes. So the simulation frameworks is allowing us to understand how the accuracy can vary if we vary a number of different parameters, such as the targeting formula, the number of users that we monitor, the number of users that receive a particular ad. The problem is that whenever you rely on simulations to explain how a system would work, the problem it might be that it doesn't realistically, the simulations are not realistic. So the crucial thing that we checked is to see whether our estimators are consistent between real-world simulations, real-world experiments, and simulated experiments. For example, if in the real world our inference is not able to accurately infer a particular formula, would it also be inaccurate in our simulated experiments? So what we did for this is that for each real-world experiment, we simulated 10 experiments that were trying to keep the same targeting formula, number of monitored users that receive the ads, to have the same conditions as the real-world experiment. And what we found out is that over 82% of our experiments were consistent. So this is a remarkable result because we are making a number of assumptions about the real world, that it's simplifying its complexity. And we also observed that the inconsistency can largely be explained by biases in our monitored users. Okay, so with this simulation, we did over 880,000 runs where we varied different parameters. And here are the two of the most interesting results. So in the first plot, you can see how the accuracy of the inference varies with the number of users, monitored users, that received an ad. And you have different lines that correspond to targeting formulas that are either very broad, like users interested in entertainment and movies, or that they are very precise. So what you can see here is that as soon as an ad is received by 10 or more monitored users, we can expect an accuracy of over 90%. Yeah? So this is a very strong result because we can link accuracy to something that is easily measurable. In the second result, we look at how the accuracy varies with the number of monitored users. And you can see that two of the lines correspond to users that have, to runs that were received by 10 or runs with ads that were received by 10 or more users or less. So what you can see here is that increasing the number of monitor users does not necessarily play an effect over the accuracy of the results, provided that the ad is received by 10 users. What it does play a role is that it increases the likelihood that an ad is going to be received by 10 or more users. Okay? So, just to wrap up, so in this work, we try to bring some solid proof that collaborative ad transparency, it's working in real world. And we did a bunch of real-world experiments, simulations. We checked the consistency between them, and we try to have accuracy where we have confidence in this accuracy. Of course, there are a number of limitations. We only tested targeting formulas with 2 attributes. We are also making Bernoulli assumptions of the ad delivery process. Nevertheless, this method, it's feasible to be implemented in practice because we can account for biases in the monitored users, and we can infer users' characteristics from their ad preferences page. So just to finish up with an important message, monitoring tools are very important for auditing and enforcing policy. So please do consider to either install our tool or tools from other groups. Thank you very much.
All right, let's thank the speaker. Okay, so in the interest of time, I think we have time for one question, modulo the tech issues that we had. And I will, go ahead.
So first off, you said legally it is allowed to have micro-targeted ad as long as it's transparent. It was in your third slide, if I recall.
No, I mean, for now you can have micro-targeting. There will be some restriction on micro-targeting, especially for political ads, but there are not many restrictions on how you can micro-target their ads. What it will be implemented is that they will be required to provide some transparency into the targeting process.
I see. And to be able to implement this in a large scale, to be able to see more patterns than, I don't know, even more complicated patterns as well.
Yeah.
Do you expect people would trust to participate because you're basically building and gathering enough information that is actually needed to target with ads, right? To be able to infer that.
I mean, of course, this is the biggest difficulty. Yeah, you need to convince people to provide some of their personal data to help research. But you do see in other disciplines, like in medicine, people are donating blood. Here, you can see the same thing, trying to ask people to donate data about the services that they are receiving. So it's now people are not used to it, but my hope is that provided that we can provide them with reliable, trustworthy monitoring tools, they will be more willing to provide this data because it's really important. This is like the biggest difficulty that we currently have.
Thank you.
All right, then let's thank our speaker and all the speakers in this session again.